everyone, we're taking a deeper look at inequalities. This is solving inequalities. Day two. Um, I'd like to start with some bell work um, and ask the question, where do critical numbers come from? Um, so critical numbers, where do they come from? Critical numbers come from solving equations and setting denominators equal to 0. Remember, you've got to find the critical numbers. If you don't put all the critical numbers on the number line, your answer is probably going to be wrong. All right. The next question I want to ask is there a difference between critical numbers found as solutions versus critical numbers from denominators? And the answer to that is sometimes. Sometimes there is a difference. So, for example, if we have x plus 12 over x plus 2 is less than or equal to 4, I know that I'm going to get this critical number of negative 2. And even though I'm going to put a negative 2 here, and even though I see that is equal to, because this critical number comes from the denominator, it's never going to work. It's always going to be a negative. So, yeah, critical numbers from denominators have to be treated a little more carefully. All right, so when I think about today's video, I think about it as a video in 3 acts. I want to, 1, revisit rational inequalities. We ended the last video with those, but I'd like to do some more. And then I'd like to talk about, of course, absolute value inequalities. And then we need to talk about what makes the radicand non-negative. And whatever that means, I can't wait to get to that point. But let's start off with rational inequalities. Okay? So, here's my first one. X plus 12 over x minus 5 is greater than 4. Okay? We've done this, so you should be able to do this. Give this a try, pause the video, come back when you're done, or stop. So I know the first thing I'm supposed to do is change that inequality symbol to an equal sign. And then because I have an equation with a fraction, I'm going to multiply both sides by the denominator to cancel out. So now I've got x plus 12 equals 4x minus 20, or 32 equals 3x. So x equals 32 over 3. Is that the only critical number? No, there's a denominator. I've got a second critical number. Critical number of 5 came from the denominator, and 32 thirds came from the denominator. Let me just check. 4x minus 20. I'm going to add 20 to get 32. I'm going to subtract 1 to get 3x. Yep, and 5. So let's test some values like 0. 30 over 3 would be 10, and How about 20? Okay, so let's see. If I plug in a 0, I get 12 over negative 5. Is negative 12 fifths bigger than 4? No. If I plug in a 10, I have 22 over 5. 22 over 5. Well, this would be 20 over 5. So 22 over 5 is bigger than 20 over 5. And if I plug in a 20, I get 32. And on the bottom, I get 15. So this is just a little bit bigger than 2, right? Because 15 times 2 is 30. So is 2-ish bigger than 4? No. Now, what about the critical points themselves? Well, because we had just greater than, this is a no, and this is a no. If we had greater than or equal to, then 32 thirds would be a yes, and 5 would still be a no, because 5 came from the denominator. But our problem was not with an equal to, it was just greater than. So this is what we've got, and therefore your answer should be from 5 to 32 thirds. Here's our answer, okay? I think these are worth practicing a little more to get more confident and comfortable with them. How about x squared plus 2x over x squared minus 9 less than or equal to 0? Why don't you try this one? Well, welcome back. There's a lot to think about here. But remember, we do the same steps each time, so maybe that'll help. X squared plus 2x over x squared minus 9 equals 0. Then multiply both sides by, and so we end up with x squared plus 2x equals 0. Here I can factor out an x, and I get x equals 0, and x plus 2 equals 0, or x equals negative 2. Are those my only critical numbers? No, don't forget the denominator. So when I set x squared minus 9 equal to 0, I end up with x squared is 9, or x equals, that's right, don't forget the plus or minus 3. So we've got 4 critical numbers here. Let's take those critical numbers and put them on a number line and start testing intervals. We've got negative 3, we've got negative 2, we've got 0, we've got positive 3. How many intervals? Well, 4 critical numbers means 5 intervals, okay? So let's start with negative 4. Negative 4 squared is 16. 2 times negative 4 is negative 8. 16 minus 8 is 8. And negative 4 squared is 16. 16 minus 9 is 7. This is a positive number. Is that less than or equal to 0? No. Okay, now I've got to plug in a number here. And unfortunately, it's between 2 integers, so I'm going to have to plug in something like negative 5 halves. Ew. All right, so negative 5 halves squared is going to be 25 fourths. And then negative 5 halves times 2 is negative 5. Okay, so that's 20 fourths. 25 fourths minus 20 fourths is 5 fourths. Is 5 fourths, oh, and that's just the top. Damn, still got to do the bottom. All right, let's do the bottom. Negative 5 halves squared is 25 fourths minus 9, which is 36 fourths. I have a positive on the top, a negative on the bottom, and so I've got a negative number, and that is less than or equal to 0. Okay, if I plug in a negative 1, I get 1 minus 2 is negative 1. 1 minus 9 is negative 8. I have a negative divided by a negative, a positive. Is that greater than or equal to 0? No. Okay, if I plug in a positive 1, I get 3 on top, I get negative 8 on the bottom, negative 3/8. Is that less than or equal to? Yes. Look, it alternates. Not always. Remember to test the intervals and don't assume that they're going to always alternate. All right, if I plug in a 4, I've got 16 plus 8 is 24. And here, 16 minus 9 is 7. 24 over 7, is that less than or equal to 0? No. Now, this is equal to. So what do I know? Well, I know the critical numbers from the denominator are never going to be yes. But the other critical numbers, 0 and negative 2, they can't be yeses. They can work. If I plug in a 0, I get 0 over negative 9, 0 over negative 9, and that's 0. Is 0 less than or equal to 0? Yes, it is. So the same thing would happen with negative 2, but when I try 3 and negative 3, they turn the denominator into 0, and that's undefined, so they can never be included. So what's my answer here? Well, that's a no, which means parentheses. This, yes. So negative 3 to negative 2, and negative 2 works, so it gets a bracket. Union, 0 works, so it gets a bracket. And then we go out to 3, which is not included. Wow, there's a lot of thinking to do in these problems. Pay attention. It'll be just fine. It's the same steps over and over, but you do have to take them. You do have to find the critical numbers. You do have to put the critical numbers on the number line. You do have to test the intervals, and you may also really want to test the critical numbers themselves. And you do that testing in the original inequality. Don't forget to write your answer in interval notation. Okay, one last one with rationals, and then we'll move on. How about 5 over x minus 1 minus 2x over x plus 1 is less than 1? So, this is interesting, because I know the first thing I want to do is turn this into an equation. But now what? Well, I want to get rid of the fractions. And so I'm going to multiply everywhere, just like we did in solving. I'm going to multiply everywhere by x minus 1 times x plus 1, x minus 1 times x plus 1, x minus 1 times x plus 1. I'm going to multiply everywhere by the least common denominator to cancel these things out. And so now I'm going to have 5x plus 1 minus 2x, x minus 1 equals, and when I FOIL here, I get x squared minus 1. All right, let's do some distributing. We've got 5x plus 5 minus 2x squared plus 2x, minus and minus is plus, equals x squared minus 1. Because I see these squareds, I know I have to move everything onto one side of the equation, and I don't want to have negative x squared, so I'm going to move everything over there. You might want to combine like terms first. Negative 2x squared plus 7x minus 5 equals x squared minus 1. And then move everything over there. 0 equals 3x squared minus 7x plus 4. This factors 3x, 4, and 1. I think that works. No, that doesn't work. That's where the 4 goes. And that's where the 1 goes. Remember, it's called guess and check. Don't forget to check. Minus 4x minus 3x is minus 7x. That's good. Negative 4 times negative 1 is positive 4. 3x times x is 3x squared. Okay, so where are my critical numbers? They're at 4/3 and 1. Wow, those are close together. Okay, and are those my only critical numbers? Well, the answer is no. They're not. So I've got, oh look, I've got 1 there as well. That's very interesting. I kind of want to go back and do it again and make sure it's supposed to be 1. It was 3x squared minus 7x plus 4. And I said 3x minus 4 and x minus 1. Yeah, that works. Okay. So critical numbers are at negative 1, 1, and 4/3. Okay, so let's test in our original inequality. How about a 0? So I have negative 5 minus 0. Is that less than 1? Yes. And what if I try something smaller than negative 1, like negative 2? Now I'm going to have 5 over negative 3 minus 2 times negative 2 is negative 4 over negative 2 plus 1 is negative 1. So these negatives cancel out. And now I'm looking at negative 5/3 minus 4. That's going to be a negative number. That's definitely less than 1. So that's a yes also. What if I plug in a 2? I'm going to have 2 minus 1, which is 1, so I have 5. And then over here, I get 4 over 3. 15/3 minus 4/3 is 11/3. Is that less than 1? No. And now I need a number in between 3/3 and 4/3. Ew. 3 1/2 thirds? Well, 3 1/2 thirds is 7/6. Ew. Really don't want to plug in 7/6. So 7/6 minus 6/6 is going to be 1/6. And that's going to be the same as 30. And then we have a minus. 2 times 7/6 is 7/3. And 7/6 plus 6/6 is 16/6. So let's flip and multiply. And that becomes a 2. And I get 14 over 13. That's bigger than 1. But that was only that. It's 30 minus that. Well, 30, and this is just near 1, that's definitely going to be bigger than 1. So that's a no. So it looks like my solution is this over here. Now, what about the critical points themselves? Well, I don't have an equal to sign here. So the ones I got from solving are going to be no. And these denominators are always no. So my answer then is negative infinity to negative 1. Don't use negative 2, your test value. Use negative 1, the critical number. Union negative 1 to 1. Okie doke. All right. Inequalities. You can do it. Our next type of inequality is absolute value inequality. Let's start off gently. So how about absolute value of x? Ooh, let's give it a title. To absolute value inequalities. Okay, so our first problem, absolute value of x is greater than 1. Now, you know what happens here is people say, okay, x equals 1, greater than 1, that's my answer, and that's not right. So remember, we want to find critical numbers. We find critical numbers by turning the inequality into an equal sign. Now we have to solve the absolute value equation. Remember, when we were solving absolute value equation a couple of assignments and videos ago, we had to write the positive component, but we also had to write the negative component. We take those critical numbers and we put them on a number line, and then we test values in the original inequality. So if I plug in a 0, is 0 greater than 1? No. If I plug in a 2, absolute value of 2 is 2, is that greater than 1? Yes. If I plug in a negative 2, the absolute value of negative 2 is 2. Is 2 greater than 1? Yes. And no equal to, so this is no, and this is a no. You can, of course, always plug the number in. 1, absolute value of 1 is 1. Is 1 greater than 1? No. So my solution here will be negative infinity to negative 1 with a parenthesis, union parenthesis 1 to infinity. Okay? Please, you've got to remember the positive and negative component when you deal with absolute values. Okay? So let's start making the problems a little more exciting. Absolute value of x minus 5 is greater than 4. And you know, remember, you can think about this graphically. We know absolute value of x minus 5 is the absolute value graph, shifted right 5. And this is the line y equals 4. And we're asking when is the absolute value graph above the horizontal line? So over here and over here. We're going to have two intervals. We know this. It didn't take me that long to think about this graphically. It's worth thinking about things graphically. All right, so let's make our absolute value of x minus 5 equal to 4. We'll write our positive component. We'll write our negative component. I get x equals 9. I get x equals 1. I'll put those numbers, positive 1, positive 9, on my number line, and I'll test the intervals. If I plug in a 0, I get negative 5. Absolute value of negative 5 is 5. Is 5 greater than 4? Yes. If I plug in a 2, 2 minus 5 is negative 3. Absolute value of negative 3 is 3. Is 3 greater than 4? No. And if I plug in a 10, 10 minus 5 is 5. Absolute value of 5 is 5. Is that bigger than 4? Yes. And what about the critical numbers themselves? If I plug in a 1, 1 minus 5 is negative 4. Absolute value of negative 4 is 4. Is 4 bigger than 4? No. And that's going to happen over here as well. So my solution, negative infinity to 1, union 1 to infinity. All right? Okay, so let's be thinking about writing that positive and negative component. Why don't you try this one? 2x plus 1 is less than or equal to 11. All right, give that one a try. Ah, you're back. Excellent. So remember, we're going to start off with turning the inequality into an equation. We'll write the positive component. We'll write the negative component. We solve this equation. We get 2x equals 10, or x equals 5. And here we get 2x equals negative 12, or x equals negative 6. Take those critical numbers and put them on a number line. And then we test the intervals. How about negative 10, 0, and 10? Okay, if I plug in negative 10 in here, I have negative 20 plus 1 is negative 19. The absolute value of negative 19 is 19. Is that less than or equal to 11? No. If I plug in a 0, I get 1. Absolute value of 1 is 1. Is 1 less than or equal to 11? Yes. And if I plug in a 10, I get 21. Absolute value of 21 is 21. Is that less than or equal to 11? No. And the points themselves? Well, if I plug in a 5, 10 plus 1 is 11. Absolute value of 11 is 11. Is 11 less than or equal to? Yes. And this is a yes as well. So my answer comes in this form. Okay? Okay. How about this one? Absolute value of x minus 5 is less than negative 1. Okay. So we do x minus 5 equals negative 1, and then I write the positive component, and I write the negative component, and I solve. I get x equals 4, I get x equals 6, and I put 4 and 6 on the number line, and I test the intervals. Okay, how about 0, 5, and 10? If I plug in a 0, I get absolute value of negative 5, which is 5. Is 5 less than negative 1? No. If I plug in a 5, 5 minus 5 is 0. Absolute value of 0 is 0. Is 0 less than negative 1? No. Uh-oh. What about 10? 10 minus 5 is 5. The absolute value of 5 is 5. Is 5 less than negative 1? No. Huh? Let's plug in 4. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. Is 1 less than negative 1? No. And if I plug in 6, 6 minus 5 is 1. The absolute value of 1 is 1. Is 1 less than negative 1? No. This is no solution. Now, how could I have known that without doing all this algebra? Let's think about this graphically. This is the absolute value graph shifted right 5. There's our absolute value. This is the horizontal line y equals -1. This is asking us the question, when is the absolute value graph below the horizontal line? Is this ever below that line? No, never. And that's why we kept getting no everywhere. Because this never happens. This is no, 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 no. Right? How about this one? Absolute value of x minus 5 is greater than -1. Well, we already know that 4 and 6 are the critical numbers, because the only thing I did from the last problem to this one is change the direction of this inequality. And instead of getting no, 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 we're going to get yes, 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 yes. And this is going to be then negative infinity to infinity. And how do I know this? Well, let's think about this graphically. What are we talking about here? We're talking about this absolute value graph shifted over 5. We're thinking about the horizontal line, y equals -1. And we're asking the question, when is the absolute value above the horizontal line? Well, this absolute value is always above, right? And that's why we get all these yeses, and that's why that's my answer. Okay? So thinking about this graphically can help inform us as to whether we're doing the algebra right, but it can also make the algebra go really fast if we're thinking about it. Okay, there's one or two more of these that I'd like to look at with you. How about absolute value x plus 14 plus 3 greater than or equal to 17? Will you please try this one? And remember, this is a 17. Okay, pause your video, try this one, come back when you're done or need help. Okay, welcome back. So, I'm supposed to turn this into an equal sign, and then many students forget that they need to isolate the absolute value before writing the positive and negative components. You really have to do that. If you don't, you've got a problem. So I've got to subtract 3 from both sides. That's the value of x plus 14 equals 14. And so now the positive component, x plus 14 equals 14, means x equals 0. And x plus 14 equals the negative component, negative 14. So x equals -28. So we've got 2 critical numbers, -28 and 0. Let's take some test values from these 3 intervals of 1, -1, and -30, and plug them into our original inequality. Okay, if I plug in a -30, -30 plus 14 is -16. The absolute value of -16 is 16. 16 plus 3 is 19. Is that greater than or equal to 17? Yes. If I plug in a -1, -1 plus 14 is 13. Absolute value of 13 is 13, plus 3 is 16. Is that greater than or equal to 17? No. And if I plug in a 1, I get 15. Absolute value of 15 is 15, plus 3 is 18. Is that greater than or equal to 17? Yes. And the numbers themselves, if I plug in a 0, 17 does equal 17. And if I plug in a -28, -28 plus 14 is -14. Absolute value of -14 is 14, plus 3 is 17, and 17 can equal 17. So our solution here then would be that negative infinity to -28 bracket union bracket 0 to infinity. All right, remember, if you have questions about this stuff, please ask them. Please ask your questions. And remember, with absolute value, to isolate the absolute value before making the positive and negative components. So will you please practice that on this one? That's 10 in the absolute values. Okay, solve this inequality, come back when you want to talk about it, or check your answer. Hey, welcome back. So I'm going to start, so I don't forget, I'm building long-term brain memory here by turning this into an equal sign. Now I have to isolate the absolute value, so I'm going to subtract 1 from both sides. Now I need to divide by 2, because all of this is segment when I'm solving. So I'm going to have absolute x plus 10 there. Absolute x plus 10 equals 4. Now I can write the positive and negative components. I got x plus 10 equals 4. I got x plus 10 equals negative 4. I get x equals negative 6. I get x equals negative 13. I take my critical numbers and put them on my number line, and then I test the intervals. I got negative 20, negative 10, and 0. So if I plug a negative 20 in here, negative 20 plus 10 is negative 10, the absolute value of negative 10 is 10. 10 times 2 is 20, 20 plus 1 is 21. Is that bigger than 9? Yes. Now I'll plug in a negative 10. Negative 10 plus 10 is 0. So 2 times 0 is 0. 0 plus 1 is 1. Is 1 greater than or equal to 9? No. And now I'll plug in a 0. 0 plus 10 is 10. 2 times 10 is 20. 20 plus 1 is 21, and that is bigger. And the points themselves are going to work yes and yes. But if you're not sure of that, then by all means, test the points in the inequality. So your answer should be negative infinity to negative 14. Remember, please don't use that. Use that here. Negative 14 with a bracket. Union, 6 is included, or negative 6 is included to infinity. Okay? So there's absolute value inequalities. And now finally, the last one. Do you remember this from the beginning of the video? What makes the radicand non-negative? Huh? Okay, so radicand is all the stuff under the radical sign. Non-negative, that's 0 or positive. Hey, you know what this is? We're wondering when the stuff under the radical is 0 or positive. We're wondering when the stuff under the radical is greater than or equal to 0. This is asking us to do those domain problems again. When they ask us the question, what makes the radicand not negative and non-negative, they're asking, when is the stuff under the radical greater than or equal to 0? So let's do a couple. How about this one? Square root of x plus 5. What makes the radicand non-negative? Well, it's when this stuff is greater than or equal to 0. And so I get x is greater than or equal to negative 5. Now, because this is an inequality, we could always turn it into an equation, get a critical number, and then we could test that critical number in our original inequality. And we could see, oh yes, negative 5 is included because 0 can equal 0. And if I plug in a 0, is 5 greater than or equal to? Yes, so all these numbers over here would. And if I plug in a negative 10, negative 10 plus 5 is negative 5. Is that greater than or equal to 0? No. So my answer here is going to be negative 5 to infinity. Really, these are just asking the domain again. This is the domain. This is the domain of this square root graph shifted left 5. So when you see the directions, what makes the radicand not negative, really they're just asking you for the domain. So let's go about doing some domain problems here. How about square root of 3 minus x? What makes the radicand non-negative here? Or what's the domain of this? Give this one a try. Come back when you're done. Hey, welcome back. So I know I'm supposed to set the stuff under the radical greater than or equal to 0. I like adding x to both sides. 3 is greater than or equal to x. But if I read it this way, x is less than or equal to 3. Now, you may be troubled by that, but guess what? That's okay because, remember, we're supposed to be finding critical values. Put your critical value on, and then go back and check in the original inequality. Okay, so here's my original inequality. I'm going to plug in a 0. 3 minus 0 is 3. Is 3 greater than or equal to 0? Yes. What about plugging in a 4? 3 minus 4 is negative 1. Is negative 1 greater than or equal to 0? No. And what about a 3? 3 minus 3 is 0. Is 0 greater than or equal to 0? Yes. So, my domain, or what makes the radicand non-negative, negative infinity to 3 with a bracket. Okay, I think you can do those, and I think I'm all set. Let's just quickly review. We talked about rational inequalities, and we learned or were reminded that critical numbers come from the denominator as well as solutions. We talked about absolute value inequalities, and remember, you need to isolate the absolute value before writing the positive and negative components. And then what makes the radicand non-negative? Well, that's just asking us what's the domain. You know, just to be sure, let's ask, I want to do one more of these. How about x minus 2, x plus 3 squared, and x minus 4 is less than 0. Okay? Give this one a try. We'll call this a closure problem. It's certainly an inequality, so please solve this inequality. Come back when you're done, and we'll call it. Okay, were you able to find critical numbers at negative 3, positive 2, and positive 4? I hope so, because you were supposed to set this equal to 0, and then set each of these factors equal to 0. This one gives you this one gives you this one gives you this. Okay, so what was our inequality? We had less than or equal to. Okay, so I need to test these intervals. Okay, so I'm going to use negative 4, I'm going to use 0, I'm going to use 3, I'm going to use 5. And negative 4 minus 2 is negative 6. Negative 4 plus 3 is negative 1, but negative 1 squared is positive 1. And negative 4 minus 4 is negative 8. So I've got a negative times a negative, which is a positive. Is that bigger than 0? No. If I plug in a 0, this goes away, this goes away, this goes away. Negative 2 times 9, which is negative 18, times negative 4 is going to be a positive number. That's not less than 0. And if I plug in a 3, I have 1 times 9 is 9, times negative 1 is negative. So this one is a yes. And if I plug in a 5, I get 3 times 64, that's positive, times 1, that's still positive, so that's a no. Okay, so I'm going with that, sorry, because I want this to be a no, and this to be a no, and this to be a no. So my answer is equal. Okay, now let's see about graphing this. We know we have x times x squared times x, so we have x to the fourth with a positive leading coefficient, so we go up over here and up over here. I pass through at 2, I bounce at negative 3, and I pass through at 4. So I pass through, and I bounce. And we're asking the question, when is the polynomial below the x-axis? Just here. So thinking about these graphically can really be helpful. All right, after this video, we're just reviewing for our Algebra Basics test. Please start reading the notes. Please watch the videos again. Please make sure you're comfortable with all this material. Please ask more questions than you're asking. Have a great day.